The goal is to isolate x, so you'd first minus 5 from both sides, making it negative 2x is less than or equal to 2, and then you divide both sides by negative 2. Now because you divide by a negative, the new rule is that you have to reverse the inequality sign, so the less than turns into a greater than or equal to. So greater than or equal to means you're going to have a closed circle, so that makes your only options C or D, and then it's greater than, so you want the arrow to point to the right, so that would make your final answer C. To find the slope of the line, you use the formula y2 minus y1 over x2 minus x1. Over here I've labeled my points, and then down here I've just substituted in. So 13 minus 10, that's y2 minus y1 is 3. 6 minus 5, x2 minus x1 is 1. 3 over 1 is 3. That's your slope. For the second example, I use the same formula, and again started by labeling the points. y2 minus y1 would be 8 minus 3. Here you're doing x2 minus x1, which is 3 minus negative 7. You can change that to plus positive, so you end up with 5 over 10, which is 1/2. And on the last example, dealing with slope, same formula. y2 minus y1 is 0. 9 minus 4 is 5. 0 divided by anything is 0, so we end up with a slope of 0. Remember to find an x-intercept. You change y to 0, so in this formula, in this equation right here, I've replaced y with 0 and then did the math to find x. So 2 times 0 is 0, 3x plus 0 is 3x, and then to isolate x, I divided both sides by 3, making the x-intercept 4. On a graph, that would mean that the line crosses the x-axis 4 spaces to the right. So if you have your xy axis, you go 1, 2, 3, 4, that would be your x-intercept. To find the y-intercept, you change x to 0 and do the math. So 3 times 0 is 0. 0 plus 2y is 2y. To isolate y, you divide both sides by 2. Your y-intercept is 6. On a graph, that would mean that the line crosses the y-axis 6 spaces up. So on this example, it combines both x and y-intercepts and the graphing portion. So over here, I did the x-intercept by making y 0. So 5x minus 4 times 0, remember that becomes 0, so you're left with 5x. And then to isolate x, you divide both sides by 5. Negative 20 divided by 5 is negative 4. So your x-intercept is 1, 2, 3, 4 to the left because it's negative. The y-intercept, I changed x to 0. And then don't forget that that negative sign comes along. To isolate y, I divided both sides by negative 4. The y-intercept is 5. 1, 2, 3, 4, 5. Connect with a straight line. When you're rewriting in slope-intercept form, that means to isolate y. So first, and you still follow reverse PEMDAS. So first I minus 4x from both sides. These aren't like terms, so the best I can do is just say 10 minus 4x. Y is still not isolated. I have to divide both sides by 2, and then you use the beans. So 10 divided by 2 is 5, minus 4 divided by 2 is 2x. That has an x attached to it. So y equals 5 minus 2x, or plus negative is another way that you could write it. To identify the slope in the y-intercept, first y needs to be isolated, which it is, and then I just match up with the formula y equals mx plus b. M is a slope. It's always the number that's multiplying x, so the slope is 5. The y-intercept is the number that's being added or subtracted. In this case, that would be 4. Writing the equation in slope-intercept form, your goal is to find m and find b and put them into this formula. So you need to know both m and b. And in this case, they tell you the slope, which is m, so that can take the place of this box, and they tell you the y-intercept, which is negative 4. So this one, they give you all your information. You just plug it in, y equals 7x plus negative 4. On this next example, they tell you the slope, so you're able to fill the first box, so the y equals 3x. But they don't tell you the y-intercept, and if you look at this point, that's not the y-intercept, because on a graph, that would be over 1 up 6, and it's not touching the y-axis. But what we can do is label them x and y, and so now we have an x, a y, and an m, so I can plug in those numbers here. So y is 6, m is 3, x is 1, and so now I can isolate b. 3 times 1 is 3. To get b isolated, you minus 3 from both sides. b is 3. But don't forget that you're not just trying to find b. You want to write the equation of the line, which means you have to fill these boxes when you're done. So we already knew the slope. That was 3, and now we have our y-intercept, which is also 3. So y equals 3x plus 3 is the final answer. This example, number 38, is a little different because you're given two ordered pairs. So the first thing you can do with those two ordered pairs is find the slope by using the slope formula. So y2 minus y1, 10 minus 4 is 6. x2 minus x1, 8 minus 2 is 6. 6 over 6 is 1. So I know this first box is going to get filled with 1 because that's my slope. But I don't know my y-intercept, and neither of these ordered pairs are the y-intercept. None of them touch the y-axis. So what I can do this time is replace y, m, and x. I know m, which is my slope, has to be 1. To replace y, I can either replace it with 4 or 10, and I chose to replace it with 4, which means that x has to get replaced with 2. So I end up with 4 equals 2 plus b. To isolate b, I subtract 2 from both sides, so b equals 2, and so now I can fill that box. So y equals 1x plus 2. Your objective on this kind of a problem is to fill the 2 boxes. The first box is the slope, the second box is the y-intercept. 38 and 39, they're the same kind of problem. So first I find the slope, y2 minus y1, but it's minus a negative, so you can change it to plus positive. Negative 4 plus 2 is negative 2. 7 minus 6 is 1, so your slope is negative 2. So that's your first box. You still need to find b. We know that negative 2 can take the place of m. Y I replaced with negative 2, which means x has to get replaced with 6. I could have also chosen this ordered pair, I just didn't. Negative 2 equals negative 12, because that's negative 2 times 6 plus b. To isolate b, you get rid of negative 12 by adding it to both sides. Negative 2 plus 12 is 10. So now I know to put 10 in my second box. So y equals negative 2x plus 10. So this example is similar to what we did on the previous page, but you're just given a graph. So the first thing you have to do is find the slope. So on a graph, the easiest way to find the slope is to do rise over run. So the rise between these 2 points is 1, the run is 3, which makes it 1/3, but then if you look at the slope, it's going down from left to right, so the slope is negative 1/3. Don't forget that if it's negative, you need to include that. So that would be the first, negative 1/3 would fill my first box. I still need to find the y-intercept. I can just actually look at it and see where the line hits the y-axis. So 1, 2, 3, 4, 5. That's my y-intercept. To graph using slope-intercept form, the first thing that you graph is the y-intercept, which in this case is negative 2. So that means the line's going to cross the y-axis down 2 spaces, and you put a point there. And then you go where the rise and the run tell you to go. Remember that the slope, which in this case is 3/4, if I match it up with rise over run. So this tells me to, starting here, to go 3 rise, 4 run. So 1, 2, 3 is my rise, 1, 2, 3, 4 is my run. I put a point. 1, 2, 3 is my rise, 1, 2, 3, 4 is my run. I can go back to the start and go in the other direction. 1, 2, 3, I can go down, but then I would just have to go backwards. So now I have a nice positive sloped line, which is what I expect. So these top 2 examples are similar to what we just did on the previous page. So you're going to start by graphing the y-intercept. So on the first, number 42, the y-intercept is 1. So I start by going up 1. And then my slope is 5, which I can think of as 5 over 1. And then I can match that up with rise over run. So I'm going to rise 5, which is my up and down. So I'm going to go 1, 2, 3, 4, 5, run 1. And then I can go in the opposite direction. So I can go down 5, 1, 2, 3, 4, 5, as long as I go backwards 1. If you connect, you have a positively sloped line. Over here, my y-intercept is negative 3, so that means I start my graph down 1, 2, 3. And this time my slope is negative 1/3. So this time my rise is negative 1. So I'm going to go down 1, and then my run is 3. Down 1, right 3, and then I can go up 1 and backwards 3. So in this problem, we have a right triangle, and I can assume, since they told me it was a right triangle, that's my right angle. I'm missing the side opposite the right angle, which is my hypotenuse. My formula is the Pythagorean theorem, a squared plus b squared equals c squared, and I have the 2 legs, which are a and b, so I can substitute in. So I have 6 squared plus 8 squared equals c squared. 6 times 6 is 36, 8 times 8 is 64. I just bring down my c squared. 36 plus 64 is 100, so I end up with 100 equals c squared. That was in the red, but that's not what I want to know. I want to know c. To get c by itself, you would square root both sides. So now the square root of c squared is c, so c is isolated, and the square root of 100 is 10, so that side would equal 10. Same type of a problem down here, except this time, because I'm given the side opposite the right angle, over here, 7. 7 is the side opposite. That means 7 would take the place of c in the Pythagorean theorem. 5 can either go in for a or b, it doesn't matter. I could have kept this as a the whole time. but otherwise you just do the math. So x squared plus 5 squared equals 7 squared. 5 squared is 25, and 7 squared is 49. Everything else comes down. To isolate x squared, you start by subtracting 25 from both sides. X squared equals 24, but you don't want to know what x squared is. You want to know just x, so your last step is to take the square root of 24, which if you use a calculator, you'll get about 4.9. In order to decide if three sides can form a right triangle, you need to use the Pythagorean theorem. A squared plus b squared equals c squared. And when you're given your three sides, whichever the longest side is, which in this case is 15, must take the place of the hypotenuse, or c. So I have to make sure I put 15 in the place of c. The other two, it doesn't matter, and then I just do the math and see if it works. So 9 squared is 81, 12 squared is 144, 15 squared is 225. If you add 81 and 225, they equal each other. So then your answer is yes. This would be enough work, but this is the only work that would be acceptable to get an answer of yes. You can't just say yes or no. Square root of 81, the number times itself that equals 81 is 9. This is just asking for the square root of 100, which is 10, and then make it negative when you're done. 40, so we pick the two numbers, one above and one below 40 that we know the square roots of, so that would be 49 and 36. But then you actually take the square root of them, so 6 and 7 are the two numbers that the square root of 40 lies between.